In this video, we will discuss the inverting amplifier. This is the basic model of an inverting amplifier. When you have an op-amp circuit that looks exactly like this, then you actually have a simple equation. VO equals VI times negative RF over RI. You can see that the amplification of the input voltage is simply the ratio between RF and RI. Very convenient. There are four basic useful types of amplifiers that we'll be showing you throughout these videos. However, not all op-amp circuits behave precisely like those four amplifiers because they may have other bits in them, but those four amplifiers will serve as some building blocks for your future use of op-amps, which exists and is nice. In order that you won't be thrown off if an op-amp is being used in a way differently than the four methods we'll be teaching you today, I will analyze this circuit to demonstrate the reality of this equation. Remember the fundamental assumptions of op-amps. These two voltages are the same relative to the ground. That means that because this voltage is zero, this voltage is also zero. Thus, we now know the difference between this voltage and this voltage. It's simply VI, and so we can determine the current across Ri. This current, which we shall call I1, is equal to VI over Ri. Now we turn to the current assumption. There is no current in this branch, and the current in this branch is VI over Ri. What is the current in this branch? It is, of course, I1, which equals VI over Ri. Thus, we can determine the voltage drop across RF. The voltage drop, V, is equal to VI over Ri, which is the current, times the resistance, RF. The voltage at this point is therefore 0 minus this voltage drop. So V0 is equal to negative VI over Ri times RF, which can be rearranged into negative RF over Ri times VI. Note that the fundamental assumption of current has nothing to do with this point, only with these two branches. And if you're wondering whether you can use KCL at this point, it won't be very useful to you. You can really only determine the current here based on whether there's, well, for example, a resistor attached to it. Then you can use the voltage and the resistance to determine the current. We will now analyze a circuit similar to an inverting amplifier with a slight hiccup, this 2-volt battery. First, consider the fundamental assumption of voltage. What is the voltage at this point? It is 2 volts. Which means, and so we're going to scaffold our knowledge, this must be a 4-volt drop. Therefore, by V over R, there must be 0.2 milliamps going through this resistor. Now consider the fundamental assumption of current, which says that these two currents are 0. What is the current in the 40 kilo-ohm resistor? It is, of course, also 0.2 milliamps. Thus, the voltage drop across this resistor is 8 volts. Because this point is 2 volts and this drop is 8 volts, this point must be negative 6 volts. And we now have VO. One thing interesting to note here is that the voltage drop across this resistor got amplified by 2, which is the ratio between 40 kilo-ohms and 20 kilo-ohms. So it may be that for any circuit, no matter what weirdness is going on here, this voltage drop is amplified to this voltage drop. But don't take my word for it on that one. Always analyze your op-amp circuit.